Now we are in 88th question. The question I put in the description box. Right now I'm reading. The question is, a train leaves a station A for station B. The train travels along a straight line without any halts between the station. During the first and last 200 meters of its journey, the train has a uniform acceleration and retardation, both of them of 1 meter per second square respectively. For rest of the journey, the train maintained a uniform speed. With this information, we have to calculate average speed of the train, given that the distance between the two stations A and B is 4 kilometers. I have presented this information in form of a diagram here. So there is a station A, station B. Distance between station A and B is 4 kilometers, which we will take as 4,000 meters. Then in the first 200 meters and the last 200 meters, the train travels with a uniform acceleration of 1 meter per second square in the first. In the last 200 meters, uniform deceleration of 1 meter per second square. And the remaining part of the journey means 4,000 meters. From that, we have to subtract the first 200 and the last 200, means 4,000 minus 400 means remaining 3,600 meters a distance. That means between C to D, the body or the train travels with uniform velocity. With this instruction or information, we have to find the average speed. So, since we have to find the average speed of the whole journey, we should know that average speed is total distance traveled by total time. So total distance is 4,000 meters, but we have to find total times. That means time taken from A to C, time taken from C to D, then time taken from D to B. So the 3 times we have to find. So total distance is already ready. We are ready with the total distance. So time taken from A to C. To find time, just see what informations we are having. We know that the train started from rest. So initial velocity is 0. Distance traveled in the first 200 meters. So we know distance, we know acceleration. We can go for the second equation of motion. So I am using second equation of motion to find distance. This is distance from A to C. So S is equal to UT plus a half AT square. So it's not vertical, it's a linear acceleration. So A. So this is a 200 meters. Initial velocity was 0, so this part is 0. So half acceleration is a 1 meter per second square, and time is what we are supposed to find. So time from A to C, so T square. So here we can go for a simple cross multiplication, and time taken by the train to travel from A to C is T square is 400, and here we can understand that T is root 400, which is 20 seconds. So from A to C, 20 seconds is the time taken. Now let's remember that, or let's understand that first 200 meters of the journey and the last 200 meters of the journey, the train had uniform acceleration and uniform retardation. So time taken from A to C should be same as the time taken from D to B. So this duration is also 20 seconds. Now our work is to find how much time does the train take to travel from C to D, where the train was with uniform velocity. So once again we'll come to this zone and we will apply the third equation of motion. Assume that because the train started from rest, initial velocity is 0. By the time the train reached at point C, it had a final velocity of V. So we are using the third equation of motion. V square minus U square is a 2AS. So our requirement is a V square. Initial velocity is 0, so forget it. Twice acceleration. This zone is uniform acceleration of 1 meter per second square, and distance is a 200. So this, when we work out, V square is 400, and here coincidentally we are getting this is a square root of 400, and the velocity with which the train travels, the uniform velocity with which the train travels from point C to point D is 20 meter per second. So let me have the collection. So time taken from A to C is same as the time taken from D to B, both of them 20 seconds. Then velocity from C to D, which is uniform velocity, is also 20 meter per second. Now let's answer the average speed. So average speed. For that, from here to here time is 20, this is 20. So let's find how much time does speed is a distance by time. In that case, time is a distance by speed. So distance from C to D, since I am finding time from C to D. So distance from C to D is 4000 meters minus 200 plus 200, means this zone is a 3600 meters a distance. So 3600 meters. And what speed? Speed is a 20 meter per second. So 20 meter per second. Our answer will come in terms of seconds. Okay, so this is 180 seconds. Fine. So let's find average speed. So average speed of the total journey is a total distance. Total distance is 4000 meters. And then time taken from A to C is 20 seconds. Time taken from C to D is 180 seconds. And then time taken from D to B is once again 20 seconds. So average speed is 4000 divided by this turns out to be 220. So 220. We have some simple cancellation. So let's apply the 2 table. We have 11 and we have 200. So we have here 200 by 11. We can convert this to mixed fraction. So let's do that. So 200 when we divide by 11. So can't go for 2. So let's go for 1. So it's 11. So we have a 9. Drop down 0, 8. So 88. And we have here 2. So 200 by 11 is 18. 2 upon 11. 2 upon 11. And since we are talking about average speed, this is in terms of meter per second. And this is the answer.